In this video, let's have a look at applications of integrals, volumes of revolution. Let's start with finding the volume generated when the region under the curve given by y equals f of x between x equals a and x equals b is rotated about x-axis. So this volume can be found by the definite integral from a to b pi y squared dx. Alright, suppose we need to find the volume generated when the region under the curve y equals x squared plus 1 between -1 and 1 is rotated about x-axis. So this volume can be found by taking this definite integral from -1 to 1 pi y squared dx. All we want to do is just apply that formula. So instead of y, we are going to place the function that we are given, so it's x squared plus 1, and all it comes down to just evaluating this integral. So we want to distribute these brackets. Remember, the pi is just a constant and we are going to keep it in your integral, so it becomes x squared plus double twice 2x squared times 1 plus 1 squared, which is 1. So it simplifies to x to the fourth plus 2x squared plus 1. Now we are going to pull out pi outside of the brackets. And now we are going to use the limits of integration to evaluate this. Remember, first of all, we are going to plug in 1, the upper limit, instead of x everywhere x appears. And we want to subtract -1 plugged in instead of x into the function. So it evaluates to 56/15 pi unit cubed, since we are looking for the volume. Now let's take up the second case, when your curve is revolved about y-axis. So likewise, this volume can be found by evaluating the definite integral from c to d pi x squared dy. Now let's work out. Say we need to find the volume generated when the region bounded by x cubed between 1 and y equals 8 is rotated about y-axis. Now since your integral involved y, so first thing to do is just express x squared in terms of y. So all you want to do is just grab y equals x cubed and raise both sides to the 2/3 power. So it becomes y to the 2/3, and on the other side x cubed raised to the 2/3. It implies, so 3 and 3 cancel each other out, so it's gonna be x squared equals y to the 2/3. Now we're going to grab this formula for volume, and instead of x squared, we are going to plug in that the expression we did find. So we are going to replace, in other words, x squared with y to the 2/3 and evaluate this integral. So we are going to keep pi as a constant, and we are going to apply a power rule for integration to that term. So it becomes, we are going to plug in 8 first for y and after 1 for y and subtract the numbers. So it evaluates to 3/5 pi 32 minus 1 in the brackets. So we need to evaluate also 8 to the 5/3, which is cube root of 8 raised to the 5th power. So we need to use these algebra skills to deal with this fractional powers. So it's gonna be 2 to the 5th or 32. So your final answer becomes 93/5 pi unit cubed. So that's the required volume.